Hello everyone, welcome to Binomial Theorem using Combinatorics. Now let's get started straight away. If you want to see binomial expansion in the simplest form to higher powers, be sure to check out the previous video. Otherwise, let's get started. You can see on the right hand side here, I have this image basically explaining how a binomial like this can be expressed in combinatoric form, and I'll just get started by showing this with a simple a plus b to the power of n. Now, we know from the previous episode the setting out of such things, but this is going to be using combinatorics instead of Pascal's triangle to expand higher powers. So let me just write this out first and I'll get to explaining it later. We start with n c0 a to the n b to the 0 plus n c1 a to the n minus 1 b to the 1. Then it's n to the c2 a to the n minus 2 b to the 2. Now you can see the pattern already emerging here, being the subscript letter here and the power of the second term, but also the minus of the first term. And this is basically a very simple method of... Now this pattern is going to continue all the way until you get to NCN, and then it's going to be a to the 0, or otherwise a to the n minus n, and then it's going to be b to the n. So that is going to be the final term of this expression, and this one over here is going to be the first term of this expression. So that is the basic theory of this principle. Now if we apply it to a question, we can see, say we do 1 plus 2x to the power of 13. Now using Pascal's triangle, it's obviously possible to write out a Pascal's triangle that goes down to the 13th row, but it's just realistically too difficult. So instead you can do it this way. Now if you were to do this, it would be 13c0, and then it would be 1 to the 13, 2x to the 0, right? Plus 13c1, 1 to the 12, 2x to the 1, and this would continue all the way until you get to 13c13, 1 to the 0, 2x to the 13. So you can see how this has incorporated the theory into an actual question. And you can see how the powers of both terms increase and decrease throughout the expression. And you can also see how the different numbers of in the combinatoric correspond to the powers that are with these two, well, pronumerals that have numbers at this point. So let's do an easier question. This could obviously be solved. This power of 13 could be solved eventually. It would just take longer than realistic in this short revision video. So we're going to do 1 plus 2y to the 5. And you can see it's going to start with 5c0. So you can see how this and this, this and this correspond very easily. The power of the combinatoric is obviously related to the power of this binomial. So it's going to be 5c0. Now, in the event that there's a 1 here, we can actually leave it out, but because it can be carried forward. But just for explanation purposes, I will leave it in for now. So we'll go 1 to the power of 5, 2y to the 0, plus 5c1 to the power of times 1 to the power of 4 times 2y to the 1 plus 5c2 1 to the 3 2y to the 2 plus 5c3 1 to the 2 2y to the 3 plus 5c4 1 to the 1 2y to the 4 and 5c5 1 to the 0 2y to the 5. So if we simplify this, it becomes, you need a calculator obviously, so 5c0, we already know that to be 1, so in this case we can just carry it forward, leaving it out. So this whole expression added together just here is just going to be 1 plus 5c1, which is 5, and then 1 to the power of 4 is just 1, so it's going to be 5 outside of 2y plus 5c2, which is 10, and the 1 again being carried forward outside of 2y squared, and then another 10. 5c3 is also 10. You can see that the two middle terms, or middle combinatorics here, will often both be equal, because 2 terms can be chosen from 5 the same number of ways 3 terms can be chosen from 5. So once again, just carrying forward this one, we can leave it out. It's going to be 2y to the 3 plus 5c4, which is 5, 2y to the 4, plus 5c5, which is 1, 2y to the 5. So if we do this one more time, bringing this in further, I'll scroll down a bit. This equals 1 plus 10y plus 40y squared plus 80y cubed plus, that's also 80y to the 4 plus 2 to the 5, I don't know, 32 y to the 5. And that is it. That is simplifying or expanding this equation entirely using combinatorics instead of Pascal's triangle. In my opinion, this is a better method to use, but obviously the previous video goes over where to start. Anyway, that is all for today. Thank you very much for tuning in. I will catch you later.